Hello students, today I am here with differentiation part 3 and in this section we are going to learn differentiation of exponential function, differentiation of logarithmic function. So be ready. First we shall discuss properties of logarithmic function. As you know, logarithmic function was already introduced in class 11th. So here we shall discuss about logarithmic properties of logarithmic function. First, look what is the logarithmic function. This is called the logarithmic function. Here a is base, which is if a is equal to e, then it becomes natural logarithmic function. If base is not given, suppose it is log x, then it will always be considered as natural logarithmic function. Okay, if something is given in base, then that will not called natural logarithmic function, simply logarithmic function. And if base is given, then it will be called logarithmic function. If base is not given or base is given as e, and this is called natural logarithmic function. I hope you understood it. Now we shall discuss about properties. Then log x into y is equal to log x plus log y, whatever may be the base. Okay, means log x into y. X and y should be in product form, should be in multiplication form. Then we can write it log x plus log y. So don't be confused. In log of x plus y is equal to log x plus log y. Actually there is no such formula. Okay, so this is not possible. Log is not defined for addition or subtraction both, whereas it is defined for multiplication and division. So I hope you understood it. Now log x upon y, this is division. This will be log x minus log y. And third formula is log x raised to the power y is equal to y log x. Simple. Suppose you are given 4 log 4, then you can write log 2 raised to the power 2. Now using this property you can write it 2 log 2. Okay, fourth and last is log. This is also called base change property. Suppose there is a logarithmic function and whose base is y. It can be different from y, but here we took y. So it can be written log x upon log y. Simple, no problem. Now base has been changed. Now what is base? You can choose any arbitrary base. Here it is not given base, it is not written base, so it will be a logarithmic function, natural logarithmic function. Okay, now some more important concepts about logarithmic function. Log 1 is always 0. Log 1 is always 0. and log 0 is not defined, okay, and log of any negative number minus a, suppose, then this will be complex, and we shall not differentiate them because we are dealing only with logarithmic functions which gives us real values. Also, in our entire syllabus there will be no discussion of complex functions. We are only discussing about real functions, okay. Now, how to use logarithms in derivatives, this is an important topic, and one question may be asked in your board exams. So first let us take an example. Suppose there is a function x raised to the power sine x, and you want to find derivative of this function. Then some student may do this differentiation like sin x raised to the power sin x minus 1. Okay. Here one more case is there. Suppose you want to find derivative of x raised to the power x. Then some student, what shall they do? H to the power x minus 1. Why are they using this? Because in their brain they have fit this formula: d by dx x raised to the power n is equal to n times x raised to the power n minus 1. Okay, so they applied here because they are not aware of concept, okay, but this is totally wrong. There is no such formula. Actually, in formula, n is a real number, okay, n is a real number. So first thing, this is not variable, and here sin x is variable, x is variable. It means this is the case of functions raised to the power function, like this function raised to the power function u to power v, where u is a function, let us assume it is fx, and v is another function, let us assume it is gx. Then how to find derivative of u to power v? Means if there is a function which is like this function raised to the power function, then it is very difficult to solve this using all available methods till now. So we use logarithms to find the derivative of these types of formula, these types of questions. So here formula is d by dx u raised to the power v is equal to u raised to the power v upon u dash plus v dash log of u. Okay, so you have to learn this formula. Okay, now we shall discuss some exercises of your exercise, some of questions from your exercise 5.4. Here question number 2 is d by dx of e raised to the power sine inverse x. Then the problem is with sine inverse x. So we first take in operator sine inverse x, and as we took this as in operator, so we have to differentiate it separately. Now e to power sine inverse x means e to power sine inverse x and derivative of sine inverse x will be 1 upon under root 1 upon under root 1 minus x squared. Okay, so now this is clear, and its answer is e raised to the power sine inverse x divided by 1 minus x squared. Okay, now question number 7, d by dx of e under root e raised to the power under root x. Okay, now basic problem is with this. Actually, in first instance it looks like under root x, and I told you earlier d by dx of under root x is always 1 upon 2 under root x. Remember it. So here what we did, we just taken e raised to the power under root x as an operator. Now differentiate it. Here under root x is taken as an operator. Here x will be as an operator by chain rule. So this will be treated as under root x. So its derivative will be 1 upon 2 under root e raised to the power under root x into e raised to the power x under root x, and derivative of under root x will be 1 upon 2 root x. So finally we got e root raised to the power under root x divided by 4 under root x e raised to the power under root x. We can further simplify it as per our required answer, but it is sufficient to drop here. Now move to question number 9. Divide dx of cos x upon log x. Simple, use this formula divide dx of u upon v. Then what is it? vu dash minus uv dash divided by v square. So I hope there is no problem in this formula. Okay, we can easily solve it. Now students, move to exercise 5.2, and in this exercise we are going to solve purely questions, problems based on logarithmic functions. First we discuss question number 2. Here y is equal to under root x minus 1 into x minus 2 divided by x minus 3 into x minus 4 into x minus 5. Now just write whole raised to the power half. Now taking log both sides, here write taking log both sides. Okay, log y is equal to 1 upon 2. By property of log, exponent will be outside. Log of x minus 1 into x minus 2 minus log x minus 3 into x minus 4 into x minus 5. Which property is used here? First is used log m raised to the power n is equal to n log m, and second is used log m upon n is equal to log m minus log n. So these two properties are used here. Now after applying property again, this is something like x into y. So log x into y will be log x plus log y. Same happens here, but because of this negative, it make all remaining terms negative. Now differentiating both sides with respect to x. Differentiating both sides with respect to x. Derivative of log y will be 1 upon y divided by dx is equal to 1 upon 2. 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5, because log derivative of log x is always 1 upon x, but in natural base. Okay, now cross multiply. This y will be multiplied in RHS. Now put value of y, you will get the required answer. Now move to next question. Question number 6. In question number 6, we need to find dy dx of x plus 1 upon x raised to the power x plus x raised to the power 1 plus 1 upon x. Just differentiate them individually. These are two derivatives, we need to find them. Now d by dx of x raised to the power 1 upon x raised to the power x is equal to x plus 1 upon x raised to the power x upon which formula is used? This formula is used. D by dx u raised to the power v is equal to u raised to the power v upon v u dash plus v dash log u. Okay, so we use this v upon u. Here v is x upon x plus 1 upon x into u dash, and then u dash means x plus 1 upon x dash plus v dash means derivative of x log x plus 1 upon x. Now x plus 1 upon x raised to the power x, this will become x square upon x square plus 1, and derivative of x plus 1 upon x will be, derivative of x will be 1, and derivative of 1 upon x will be minus 1 upon x squared. Derivative of x is 1 log x plus 1 upon x. Now after simplifying it, we shall get this. Okay, now similarly find the derivative for x raised to the power 1 upon x. It will become x raised to the power 1 upon 1 plus 1 upon x plus 1 minus log x upon x squared. Now adding these two, we shall get derivative of this function, something like this. Okay, and one more thing, you need to write this at last, because if you do not write this, then 1 mark will be deducted from your answer. Okay, so be careful while answering this question. Finally write whatever is asked in your question. Okay, don't take it granted. Now question number 12, x raised to the power y plus y raised to the power x is equal to 1, and we need to find here dy by dx. Now differentiating both sides with respect to x, I forgot to write here with respect to x. D by dx of x to the power y plus d by dx y raised to the power x is equal to d by dx of 1. Now d by dx of x to the power y plus d by dx of y to the power x is equal to 0. Now write this formula here. D by dx is x to the power y is equal to x to the power y, and v upon v is y and u is x, so y upon x, and derivative of u is x, so derivative of x, plus y dash, y is v is y here, y dash into log x. Now it will become x to the power y into y upon x plus y dash log x. Okay, now similarly find derivative of x and y raised to the power x. This will be derivative of y raised to the power x. Now put all these in this relation. So we got x power y to power y upon x plus y dash log x plus y power x upon y dash plus log x, y is equal to 0. Now what shall we do? We just take first derivative term at same place. So for this, first multiply x to power y and y to power x to power y and y to power x in these respective terms. After doing all this, you will get y dash into x to power y log x plus y raised to power x minus 1 is equal to minus y into x raised to power y minus 1 plus y to power x into log y. Okay, here y dash is equal to minus y to power x, y into x power y minus 1 plus y to power x log y divided by x to power y log x plus x into y to power x minus 1. Okay, so now question number 15 is the last question. Here xy is equal to e raised to power x minus y, and we need to find here dy by dx. In this case, taking log both sides, so after taking log, it will become log x y is equal to log e raised to power x minus y. Now applying properties of log x into y, log x plus log y is equal to x minus y into log y, and we all know that log y is 1 always, log e base e. Okay, it is always 1 here. So now this will become log x plus log y is equal to x minus y. Okay, now differentiating both sides with respect to x, dy by dx log x plus dy by dx log y is equal to dy by dx x minus y. Now derivative of log x is 1 upon x, derivative of log y is 1 upon y dash is equal to 1 minus y dash. Now taking y first derivative terms at one place, so 1 upon y plus 1, y dash is equal to 1 minus 1 upon x, y plus 1 upon y into y dash is equal to x minus 1 upon x. Now after solving, you will get this solution. I hope you might have enjoyed this class. Okay, if you enjoy this class, then please press like button. Thank you all for joining this class. Stay blessed. Thank you very much.